Here's the simple example. We have an industry with a bunch of producers. Each provides a fixed quantity of inputs. The treatment is to increase the productivity of those inputs. Maybe these are farmers with fixed land and labor, and an experimenter will give them fertilizer or teach them something. Maybe these are office workers who will be given some awesome AI tool. Some of the producers are put in a treatment group. The others are left out. We call this a targeted treatment. What will this targeted treatment tell us about the consequences of another experiment that differs only in that it treats all producers instead of some of them? Looking at the targeted treatment, the industry quantity goes up and the price falls. Treating the entire market will, of course, change quantity and price even more than the targeted treatment does. Now let's view these same two experiments at the firm level. Firm quantity is now on the horizontal axis. Revenue in this picture is an area. To simplify the picture, we assume that the treated and the controls have the same output and revenue in the baseline. Here's the treated. They're more productive, of course. What if, for a revenue outcome, we estimated a treatment effect as the difference between treated and controls revenue? In this picture, it's the area R4 plus R6. It is also the difference in differences. More specifically, the difference between the average revenue change of the treated suppliers and the average change for those untreated, because the two types of suppliers have the same revenue in the baseline. Throughout this video, we refer to did and treatment effect interchangeably. But that's not the effect of the treatment on the treated, because the treated lost the area R1. So did the controls for that matter. Therefore, the treatment effect on the treated, tot, is strictly less than the did. The tot could have the opposite sign. Now let's look at market-wide treatment. Price falls even further. The controls are contaminated. But the contamination is a big part of what we want to know. We call the effect of the market-wide treatment epsilon, or a scale effect. This is yet a third number, namely R6 minus the two green areas. It can have the opposite sign of did. Indeed, it will if industry demand is price inelastic. A quite general result is that the scale effect is outside the range spanned by did and tot. What we cannot say in general is whether scale and did have the same sign. This is figure 1 again. I want to address spillovers in this context. You might think that spillovers can be safely ignored when we treat just a tiny fraction of suppliers. There would be no noticeable effect on the average supplier among the controls. That's correct, but a disadvantage of a small targeted treatment, not an advantage. A market-wide treatment has lots of spillovers. Every treated supplier is experiencing a myriad of spillovers from those other suppliers, who are also treated. Market spillovers are of intrinsic interest. Any technique that makes the spillovers disappear is missing some important economics. When we reduce the extent of the targeted treatment, it moves E' toward the baseline and away from E double prime. Even more extrapolation from the targeted treatment is needed to learn about the market-wide treatment.